Hello everyone, this is my next video on your preparation for Soliton technologies. In this video, we're going to solve some questions on permutations and also on combinations. So let's get started with our video. In this video, before we get into the concepts of solving, we'll start understanding how does combination works, and after that we'll get started with our video. So initially, if I have to choose two numbers from 1, 2, 3, 4 and 5. I'll have to choose two numbers out of this. I should understand that if I take 1, 2 as those numbers, and if I choose 1, 2 as those numbers, every time I choose 1 and 2, I will also let down these numbers 3, 4, 5 on one side, which means I'm just choosing them. I'm not arranging them. So which means I choose 1 or 2, 1 and 2 here. When I take this as an array, take this together, when I choose these together, and I also leave 3, 4, 5 which is not chosen. So 1 and 2 will form a team and 3, 4, 5 will form another team. So similarly, if I choose 1 and 3, when I choose 1 and 3, I have another 3 numbers which is not chosen, that is 2, 4, 5. Exactly. So every time I choose 2 numbers here, I leave 3 numbers which is not selected. So those 3 numbers will act as another team. So in case if I have 10 people, out of which I'll have to choose 4 people in a class. So every time I choose, out of those 10 people, I choose A, B, C, D, I leave the other 6 people who are not chosen. Again, I choose another 4 people. Again, I leave 6 people who are not chosen. So every time I choose a team of 4, I leave a team of 6. So when you count all those things, we take a count of them. Every time I choose a 4, I leave a 6. Every time I choose a 4, I leave 6. So obviously those 4 people and these 6 people are going to be the same. It gives you the same answer. Similarly here we put it as 1 and 2. When I take 1, 2 here, we leave 3, 4, 5. So that's why in our combination classes at schools, they would have taught us out of 5 numbers, we choose 2 numbers. So from 5 numbers, we choose 2 numbers. It can be done in 5C2 ways. They say 5C2 is equal to 5C3. The reason why they say 5C2 is equal to 5C3 is 5 numbers can be picked out in 5 factorial ways, out of which the 2 numbers, I don't want the arrangement in them, so I divided by 2 factorial. Again, those 3 numbers also forms a team, so there also I'm not bothered about the arrangement, so I divided by 3 factorial times. So your answer would be 5 factorial divided by 2 factorial into 3 factorial, which is only going to give you 10 arrangements. That's what our answer says. We'll cross check. So the numbers that we could check right now is with this. If I choose 1, 2, the number of arrangements I could choose 2 numbers is 1, 2, 1, 3, 1, 4, 1, 5. There are 4 numbers. 2, 3, 2, 4, 2, 5. There are 3 numbers. 3, 4, 3, 5. There are 2 numbers again. 4, 5. There's 1 number. So now we'll have 4 plus 3 plus 2 plus 1. The number of arrangements are going to be only 10. The similar answer is what we've got here. So this is an understanding that we should get, that every time I choose 4 numbers, every time I choose a particular group from a group, if I have to choose 3 people from 7 people, every time I choose 3, I leave 4 people who are also forming a team. So that is where this is how this combination works, because we are not going to arrange them, we are going to only select them. So with this concept, we are going to solve some questions here. So let's get started with the questions. Okay, the first question is, how many rectangles are there in a chessboard? So if we have to count on the rectangles in a chessboard, we'll try to understand how does a rectangle work, how does a chessboard works. A rectangle can be formed in a chessboard. So we take a couple of vertical lines and we do a couple of horizontal lines. So these 2 vertical lines and these 2 horizontal lines gives you one rectangle. Similarly, if I draw another vertical line here, so these 2 vertical lines and these 2 horizontal lines can give us another square rectangle here. So obviously 2 horizontal lines and 2 vertical lines can give us one square, one rectangle, rectangle. So if that is the case, they've asked you for a 8 cross 8 grid. They've asked you for a 8 cross 8 grid or a chessboard. So we should understand the number, try to find the number of horizontal lines and the number of number of vertical lines in the chessboard. So before that, we'll try to do it for a smaller grid. maybe for a 3x3 grid, how many, we have a 3x3 grid here. So we'll try to understand how many vertical lines are there and how many horizontal lines are there. So we have 4 horizontal lines, 1, 2, 3 and 4. We have 4 horizontal lines. The number of vertical lines are going to be 1, 2, 3 and 4. We have 4 horizontal lines and 4 vertical lines for a 3x3 grid. So if it is a 3x3 grid, we get 3 plus 1, which is 4 horizontal, and again plus 1, we get 4 vertical lines. So 4 horizontal lines and 4 vertical lines. So if that is the case, out of which we'll have to find the number of rectangles that can be formed. So we very clearly understand that in a chessboard we'll have, if it is a 8x8 grid, so 8 vertical line, 8x8 grid can give us 8 plus 1 gives you 9 horizontal lines and 9 vertical lines. So if that is the case, 9 horizontal and 9 vertical, out of which I'll have to choose two lines, so which could give us a rectangle. So from 9 horizontal lines I'll have to choose two lines, so which would be 9 horizontal lines from which I'll have to choose 2 lines. It can be done in 9 factorial divided by 2 factorial into 7 factorial ways. Again, from 9 vertical we'll have 9 factorial ways we could take it, from which we'll have to take 2 factorial into 7 factorial, because these 2 lines we choose, the other 7 lines will form another team. Similarly, when I choose 2 lines, the other 7 lines will form another team which is not selected. So the number of rectangles that we could get is 9 into 8 divided by 2, 9 into 8 divided by 2 here, so which is nothing but 36 here. Again we'll get 36 here. So 36 into 36 is nothing but 1296 rectangles. We naturally get 1296 rectangles. So let's get started with the next question. So how many squares are there in a chessboard? So again we'll get into a 3x3 grid so that we understand the question even easily. So 1, 2, 3. So 1, 2, 3. So if a square has to be formed here, so what we should understand is, if a square has to be formed here, we know the number of unit squares are going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 unit squares. If it is a 2x2 square, they've asked you for the number of squares, they've not asked for the unit square. If it's unit square, it's going to be 9. Similarly, if I ask 8x8 chessboard, number of squares, many give me the answer as 64. The reason why they give you as 64 is because of the unit square they're counting. It's also about the other squares which is present here. We have 2x2 squares here. So 2x2 square is 1, 2 and 3, and we have 4. So we have 2x2 squares which is 4, and then 3x3 square is only 1. So in a 3x3 square we get 9 is a square number which is 3 square, and 4 is again a square number which is 2 square, 1 is again a square number which is 1 square. So in a 3x3 square which is given as 3x3 grid, the answer is 3 square plus 2 square plus 1 square, which means it starts from 3 and starts reducing and goes up to 1. Similar case, if it is a 8x8 chessboard, the answer may be 8 square plus 7 square plus 6 square plus 5 square, 7 square plus 6 square plus 5 square plus 4 square plus 3 square plus 2 square plus 1 square, 2 square plus 1 square. So which goes up to, starting from 8, it reduces up to 1 square. So our answer for this would be 204 squares. A very simple technique. All that we have to do is see the number of squares, and you'll have to just square them as 2 squares, unit squares, 2x2 squares, 3x3 squares, 4x4 squares, and we'll have to add them all together. So our answer is 204 squares. Next question. Find the number of rectangles in a chessboard that are not squares. In the very first question, we got the number of rectangles there. The number of rectangles in that first question also contains squares which be having the equal sides, that is the length and the breadth as equal. So those kind of, they could fall into the category of squares as well. So they do not want them to be added in this particular question. If that is the case, we know that number of rectangles are going to be 1296, out of which they don't want these squares. So which means, the total number of squares in an 8 cross 8 chessboard is 204. From the previous two questions, we've got this data. So the number of rectangles alone is going to be 2, 9. Just subtracting both of them. The number of rectangles are going to be 1092. A very simple technique. Just subtract both of them. This is the next question. The next question says, 4 unit squares are chosen at random on a chessboard. What is the probability that 3 of them are of one color and the 4th one is of an opposite color? So we'll have to take this word unit squares. They've told it's unit square. It's a unit square. So unit squares is nothing but a 1 cross 1 square. So we know from 64 squares we'll have to choose 4 squares. So that is the total number of ways in which we could choose 4 squares. So if that is the case, so number of ways in which choosing the square 4 squares would be 64 square 64c4. It's nothing but 64 factorial divided by 4 factorial into 60 factorial. The number of ways in which we could choose the 4 squares is 64 factorial divided by 4 square. We are choosing 4 squares, which would be 4 factorial. The other 60 factorial will be forming another team. So 64 factorial divided by 4 factorial into 60 factorial. The same thing, what is the probability that 3 of them are of one color and the 4th one is in opposite color? 3 of them should be of the same color, which can be white, white and white. The other one can be black, or it could be black, black, black. The other one can be white. Any of this is possible. So any of these two are possible. So if that is the case, so our answer would be, we'll have to choose one color out of them. We'll have to choose one color out of this 3 squares of one color, and the other one would be of a different color. So we know a chessboard has 2 colors only. One is black and the other one is white. So the arrangement can be black, 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 white, or white, 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 black. So from these 32, we know 32 black squares are there and 32 white squares are there. From these 32 squares, we'll have to choose 3 squares which is of one color, which is 32 factorial divided by 3 factorial into 29 factorial. This gives you 3 black squares into 1 white square would be 32 factorial divided by 1 factorial into 31 factorial. That gives you the white square. So if that is the case, 1 factorial into 31 square factorial, which gives you the number of 3 black squares and 1 white square. And we know very easily, even the 3 black squares and 1 white square will also give you the same arrangement, because out of 32 squares we'll have to choose 3 and the other 29 squares will be forming another team. And again, 32 square, the other one will have to choose 1 and the other 31 squares will form another team. So obvious it will be the same, so we'll have to multiply it by 2 because we'll get the same arrangement twice. So it is multiplied by 2. So now that we'll have to divide both of them, because 32 we'll have to just cancel out things and we'll have to get to the answer. So our answer would be, when we divided, our answer would be 32. Here also we'll have to divide this and we'll get the answer as 32 into 31 into 30 into 32 here, because divided by 31 factorial we'll get 32 here. 32 divided by 64 into 63 into 61, 62, 64 into 63 into 62 into 61 divided by 4 factorial. That division of 4 factorial will go to the numerator, so it will be 24 into 32 into 31 into 30 divided by 64 into 63 into 62 into 61, and we would get this answer into 2. We still have this 2 with us, so into 2. So when we do this, our final answer would be 640. When we divide all these numbers, we would get the final answer as 640 divided by 1320. This was a question which was asked in Soliton before 3-4 years, and I would expect a very similar solving. These kind of questions could help you to solve any questions which could be asked in this chessboard kind of questions. So let's get started with the next question. A team of 8 students goes on excursion in 2 cars, of which one can seat 5 and the other can only 4. How many ways can they travel? So this question, again, it says 5 students are taken, out of which 5 should be in one car and the other can occupy only 4. So if that is the case, we know there are two ways in which we can do it. Car 1 can have 5 people and car 2 can have 5 people in car 1 and car 2 can have 3 people, or else car 1 can have 4 people and car 2 can have 4 people. So there's two ways of doing this. So if that is the case, the number of ways of doing this is 5 people in one car and 3 people in the other car. So which can be like, if I choose those 5 people, the other 3 people will be in the other car. That's obvious. So it's again combination. So 8 factorial ways people can occupy, out of which if I choose 5 people for the first car, the other 3 people will form another team and they'll fall into the other car. Similarly, when I choose 4 people in one car, it's obvious the other car will occupy the other 4 people. So it's nothing but 8 factorial by 5 factorial into 3 factorial plus 8 factorial divided by 4 factorial into 4 factorial, which is nothing but 8 into 7 into 6 divided by 6, which is nothing but 56 here, and we'll get here 8 into 7 into 6 into 5 divided by 24 gives you 70. So I think the answer here is 126. The number of ways this could be possible is 126 ways. And this is also a previously asked Soliton question. I would like you guys solve more questions of this type so that you guys get used to these kind of questions. And I really appreciate for people who have been watching this video, and I thank you so much for your time and patience. And I would really appreciate if you guys can comment, like and share my video, and if you had not subscribed my video, I would really appreciate if you guys could subscribe. Thank you once again for your time and patience. Thank you.